review. First off, you notice I moved the C back to where it should be. So I apologize for that. There was a printing error. So it's back where it should be at that top point of the diameter. So, name these parts. Okay, chord. Well, a chord touches from one point of a circle to another. So, this is a chord. Technically, this is a chord. You know, some of you might be looking at the entire part going through, but that piece is a chord. So, when we name a chord, we can say CD. We could also say GF. I put a line segment over it. And that's what tells me that GF is just that piece, that segment, not the entire thing. Okay, a radius. Well, a radius goes from the center out. So that's a radius, that's a radius, and that's a radius. Any one of those would be acceptable for an answer. Now the most obvious one that most people are going to put is HE, but CH is perfectly acceptable, and so is FH. And again, you can also put these in any order. HF, HC, EH, FG, or GC. That does not matter. It's just the endpoints connecting that matters. Okay, diameter. Clearly only one, going from C to F. Or you could call it FC again. A central angle. That is an angle that has the center as a vertex. And the endpoints on the circle. So right there, that is a central angle. So we call it FHE or EHF. Makes no difference. Remember, we put the angle mark in front of it, EHF. Alright? Now an inscribed angle. Remember, an inscribed angle has its endpoint on the circle. So, for example, DCF is an inscribed circle. So I'm going to go smaller. Angle DCF. Also, though, you could also say GFC. Okay, that's another option. Don't have a lot of room there, so I'm not going to write it, but that would be an option for that one also. All right, a major arc. Now, I'm not going to write all these, but basically pick a point wherever you want. Start here at G, and just make sure you go more than halfway around the circle. So you'd have to go all the way up to C, or B, whatever. And just pick any three of those letters. Doesn't matter, as long as you have the endpoints, G and C on the end. But you can put F, E, or D in the middle. So this could be called G, F, C. Or you can replace the F with E or D. Alright? That's just one. I'm not going to do all of them, obviously. Too many to do right here, but just start anywhere. You know? F, go around, semicircle here, just keep going past. FGD. FGD. And put an arc mark over. That's all. So, tons of choices here. Minor arc. That's going to be a smaller one. You can do whatever you want. BC, that's a small one. DE, GF, FE, CD, any of these would be minor arcs. GB. Alright? So just pick, whatever you want. BC, as long as it's less than a semicircle. DE, etc. Alright? A semicircle. Well, the only way you can do that is starting at C and going left to right. So we can say CGF. Or we could say CDF. We could also call that CEF. Doesn't make a difference. A secant. Okay? A secant goes through the circle, kind of like an arrow shooting through a balloon. So there's only really one place for that. What? This board's really being weird. Okay, only really one place for that, and that is this right here. Okay? AC. Sorry, I got ahead of myself. That's number 10. Sorry. Down here, going through, I pay attention to myself, going through the circle would be AF. And remember, that is a ray. And in my tangent, I got ahead of myself, that would be AC. And remember, that one is just touching the circle in the one spot. Okay, before I even look over here, love this board. Before I look over here, I'm just going to look at the circle. Now, what I have here is a semicircle. So that's going to add to 180. So 80 plus 40 is 120. So I need 60 degrees here. Okay? But then this is a semicircle. So 60 plus 80 is 140, which means 40 right here. But guess what? I have a semicircle right here. 180 minus 40 is 140. And there's also the other 40 on the other side of it. So I fill in my numbers first. Now I come over here and look. KO. Where's KO? KO is right here. Well, that's 60 degrees. Boom. Like I said, I forgot to take those lines off, so don't just ignore them. M, L, N. So start at M, go around L to N. Now, you can either do this one of two ways. You can add 40 plus 80 plus 60 plus 40, or you just subtract that from the whole circle. 360 minus 140. It makes no difference. You're still going to get 220 degrees. O, M, N. So starting at O, going around M to N. Okay? So 80 plus 40, which is 120, plus 140. $260 degrees. Okay? Get a little bit messy here. All right. M. Oh, my bad. That wasn't an arc. Just pay attention to that. One other thing I was going to say is make sure you pay attention. These two are angles, not arcs. So OMN, where is that? O to M to N. Okay? That's an inscribed angle right there. The inscribed angle means we're looking at this arc right here. 60 plus 40 is 100, but then remember, you divide by 2, and that's 50 degrees. Right? Okay, M-O-N. So again, we're going to start at M, draw a line to O, and come down to N. Which arc is that? That's this arc. But being an inscribed angle, we take 140 divided by 2, and that's 70. And now we're back to arcs again, K and L. Start at K, go around N to L. So that's 40 plus 40, which is 80, plus 140, which is 220. All right. Solve for each problem. Like what we just did on a couple of those, an inscribed angle. This angle here is equal to half of this. Now you have two choices. You can just take half of 130 right away, or you can say 6x minus 24 equals half of 130. Like I said, if you want to go directly to, hey, I already know that half of 130 is 65, go for it. That's okay. You can skip that step and just put 65. Do the math in your head. And then add 24 and divide by 6, and you get 14.83 repeating. Or 14.8, I would accept either answer. Now this one is not drawn to scale. There's no way that, which looks pretty close to 90 degrees, is 115 degrees. Okay? But it doesn't matter. We're just going with the concept that opposite angles in an inscribed quadrilateral are supplementary. So we just do 180 minus 115, and x is equal to 65. And again, I know that doesn't look like 65. It's okay. Now 18. 18 is different from 16. 18 is a central angle because the vertex is here in the center. So therefore, 2x minus 5 is simply equal to 100. So if I add 5, I get 105. Divide by 2, I get 52.5. Okay, my circle got cut off here for some reason. Don't know why. Horribly finished it there. All right, here we have an inscribed angle again. You have two choices. You can say 1/2 of 68, or again, just go right to 3x minus 17 is equal to half of 68, which is 34. Up to you. Now I'm going to add 17 and get 51, divide by 3 and get, well, 17. Here, I'll finish my circle. Basically, I have vertical angles. Vertical angles are equal to each other. So I literally just set these equal to each other. I'm going to add 16 and get 56. Divide by 6 and get 9.3 repeating, or 9 1/3. Here we have a circle. 2x plus 3x minus 2 plus 5x minus 8 create a circle which has 360 degrees. I simplify and get 10x minus 10 equals 360 degrees. Add 10 to get 370. Divide by 10 and get 37. All right. Remember, you are going to have the formula here, cheat card, but when this comes outside, like so, we're going to take the big arc minus the small arc. So 3x minus x divided by 2 is equal to 25. Now I'm going to multiply both sides by 2 to get rid of this. And that gives me 3x minus 2x, which I'm just going to simplify in my head, is 2x equals 50. And so x equals 25. Same concept here. Big arc minus small arc divided by 2 equals 5x. Now you can multiply both sides by 2, but think about it. The left side is just numbers. So that's 100 minus 10, which is 90, divided by 2 equals 45. So x is 9. Now again, if you multiply by 2, you would have gotten 10x equals 90, and still got 9. Just a different way of doing it. But since there's no variables here, you can just simplify that fraction. All right, crossing inside the circle. In this case, we add 45 plus 125 divided by 2 equals x. So x is equal to 85. Find the measure of arc AB. Well, what we have here inscribed in the circle is a regular pentagon. It's regular because all of the sides are equal, which also means all the angles are equal. So I'm going to just show you how inside this regular shape, this five-sided shape, there are 5 regular triangles. And since they are all triangles in there, each one of these angles is congruent. These are 5 equal triangles. So this arc corresponds with this central angle. So if we know the measurement of that angle right there, we know the measurement of the arc. So therefore, this is a circle, which is 360 degrees, divided by 5 triangles equals 72. So AB is 72. And let's say I wanted AC. Then it would just be 72 times 2. Or if I wanted to go to this far, call it D, it'd be 72 times 3. And that's it. Okay, determine if the line is tangent or not. Well, if it's tangent, it is perpendicular to the radius. So I'm going to treat it as if it is. 5 squared plus 12 squared equals 13 squared, and test it. Remember, log the side of the hypotenuse. Now, if you know your Pythagorean triples, you know this is a right angle already, a right triangle. But you can prove it. And what you get is 169 equals 169. So that's a yes. The line is tangent. Over here, it doesn't look like a right angle, but it's going to be. Because if you know Pythagorean triples, 8, 15, 17 is also a Pythagorean triple because you get 289 equals 289. So that's a yes. Now, 28, I apologize. Also, with printing, something happened. This line right here was kind of inside the circle. It should be running like that, being tangent, and a right angle right there. So, that means I need to figure out what's going on here. Well, I know this is not drawn really to scale, but if this is 8, then this is 8. Which means, if this is 4, this entire piece right here is 8 plus 4, 12. So that's my hypotenuse, theoretically. All right? 6, 8, 12. 6 squared plus 8 squared equals 12 squared. And what you end up with is 100 and 144, which does not equal, so that's a no. Okay, 29. Remember, whoops. I like to do this to remind myself to multiply like so. So 2x times x equals 6 times 48. Well, that's 2x squared equals 288. And then if I divide by 2, I get x squared equals 144. If I take the square root, I get x equals 12. All right. Over here. Remember, the formula for this is outside times the total equals outside times the total. Now remember, a lot of people are going to want to say 9 times 9x. Well, let's go to the other side. 10 times the total. What's the total here? 18. You know that when it's numbers, because you add 10 plus 8. So why would you multiply x times 9? It's x plus 9. So what you get here is 9x plus 81 equals 180. Now, if I subtract 81, I get 99. Divide by 9, x is 11. Here, these two tangents meet at the same point out here, so they're simply just equal to each other. So if I subtract 3, I get 16. Divide by 6, I get x equals 2 2/3, or 2.6 repeating. All right, this one's a little bit different. This one is outside 12 times the total. 12 minus 8 is 4, so that's x plus 4 equals the tangent squared. So that's 12x plus 48 is equal to 576. Now if I subtract 48 and divide by 12, I get x equals 44. All right? Outside, x times the total 2x plus x, which is 3x, equals 3, the outside, times the total, 11 plus 3 is 14. So that gives me 3x squared equals 42. If I divide by 3, I get x squared equals 14. And if I take the square root of both sides, x equals 3.74 rounded. Okay, multiply this way. 16 times x equals 8 times 15. Well, that's 16x equals 120. Divide by 16, and I get 7.5. All right, almost there. A few different ways to do this problem. Okay? I can either figure out that this angle here is half of 138. Okay? And half of 138 is 69. And then I can subtract 69 from 180 and get 111. That's one way to go about it. Another way to do it is to know that if this is 138 and the whole circle is 360, if I subtract 138 from 360, I get 222. And then if I take half of that, x equals 111 degrees. Two perfectly good ways of doing it. One's not really too much faster than the other, but I just wanted you to see both. All right. Identify the center and the radius. Well, remember, the important thing here is not to say that the center is 5 comma anything. Remember, this is really this is really x minus negative 5 squared. And this is really y minus 0 squared. So that means the center is negative 5 comma 0. And the radius is just the square root of 27, which breaks down square root of 9, square root of 3 to 3 radical 3. Okay, 37. Now we're going the opposite direction. So we're going to say x minus 4 squared plus y minus negative 7 squared equals 3 squared. So just to clean it up, x minus 4 squared plus y plus 7 squared equals 9. All right. So here, I can start off at the beginning easily. X minus 2 squared plus y minus 3 squared equals the radius squared. Well, what's the radius? Well, if I have a circle, and this is 2 comma 3, and it goes through 2, 7. Well, if you think about it, that spot, 2, 7, is directly 1, 2, 3, 4 spots above. Or we can do, if the numbers weren't that nice, like let's say it was, 3, 8, you would do the distance formula. And so what you would do is 2 minus 2 and 3 minus 7, which would get you 0 plus 16, square root of 16, and the radius is 4. But remember, we need to square the radius, so that's 16. Last but not least, the drawing will probably help with this. We have a circle with a center at 1, 3, right there. And it's tangent to the y-axis. Well, tangent means it's just touching the outside of the circle, which means right here. Okay? Which means right now the radius is 1. So therefore, we just go to x minus, not 2, I don't know where that came from, x minus 1 squared plus y minus 3 squared equals 1 squared, which is 1. And that's your review.